Dr. R. Hemavati is an assistant professor in mathematics in Queen Mary's, Chennai. She has specialized on functional analysis. Having 12 years of experience in teaching, she has won various awards for her performance. She has published papers in 14 international journals, 3 national journals, and has presented papers in 10 international and in 5 national conferences. She is also one of the editors for an international journal.
Welcome to UGC lecture series. In the previous session, we were discussing about critical region and power of test. In this session, in continuance with the topic, we will work out some more problems in determining the critical region and power of test for a case study. So, the objective of this session is to work out in determining the critical region and work out in some problems in determining the critical region and power of the test. In continuance with the power of the test, this test will be called a powerful test. When the test will be called a powerful test, in the sense if the null hypothesis H naught is such that mu is equal to mu naught, then K where mu naught is equal to alpha, which is the probability of type 1 error. Therefore, we want K of mu naught to be small. We can achieve this by choosing the level of significance to be small. The power of the test should be less value. Then the test is called a powerful test. On the other hand, if mu1 is the value of mu for which the alternative hypothesis HA is true, then we want a K of mu1 to be large. In that case, 1 minus K of mu1 will be less, is the probability of type 2 error, which will be small when K of mu1 is large. So, 1 minus K of mu1 stands for probability of type 2 error, and it will be small when K of mu1 when power is large. Hence, a powerful test is one in which K of mu naught is small and K of mu1 is large whenever mu1 is not equal to mu naught. Increasing the sample size increases the power of the test. Then it becomes a powerful test. Suppose the sample size in example 7 is increased to 64. We were discussing in example 7 the sample size is 36. So, when it is increased to 64, how will you find out the power of the test? Solution goes like we have seen n is equal to now 64 and mu is equal to 12, isn't it? Mu is equal to 12 and sigma is equal to 3, n is now 64. So, Z is equal to x bar minus mu by sigma by root n, x bar minus 12 by 3 by root of 64, isn't it? That is x bar minus 12 divided by 0.375 and K of 11 we want power of the test. Power of the test is K of 11. If you want it is P of x bar minus 12 divided by 0.375 is less than or equal to minus 1.65, because of the level of significance is 5% and we know that P of Z less than or equal to minus 1.65 is 0.05 as already discussed. Okay, and Z is substituted as x bar minus 12 by 0.375. Okay, now just cross multiply P of x bar is less than or equal to minus 1.65 into 0.375 plus 12. Then P of x bar minus 11, because you want the power of the test corresponding to mu value 11 divided by 0.375 will be minus 1.65 into 0.375 plus 12 minus 11 divided by 0.375. Okay. Whatever the action you are doing for x bar, that has to be also done for the right hand side, right? X bar is less than or equal to this particular value. So, that is subtracted with minus 11 first, then divided with 0.375. This value is P of x bar minus 11 by 0.375 is less than or equal to 1.02. That is P of Z is less than or equal to 1.02. Draw the diagram, plot 1.02, Z is equal to 1 plus 1.02, just shade it, and this area is already 0.5 and this area from Z is equal to 0, this one is taken from the table. Okay. 1.02 we want corresponding to Z is equal to 1.02, the value is 0.3461, isn't it? 1.02, 0.3461. Okay. So, that is equal to, this area is 0.3461. So, the required area is 0.5 plus 0.3461, which is equal to 0.8461. Okay. So, the probability of type 2 error, this is actually power of the test. Probability of type 2 error will be, error is 1 minus k of 11, which is equal to 1 minus 0.8461, which is equal to 0.1539. This is the probability of type 2 error, which is also asked to compute. The next example is the following cholesterol levels were found in a random sample of 10 women aged 20 to 24 engaged in a low fat diet program. These are the 10 women's cholesterol levels has been given: 176, 180, 175, 186, 182, 188, 180, 186, 168 and 184. If the null hypothesis is the average cholesterol level of all women for who maintain the diet is normally distributed with mean. For all means we have to take the population mean, mu is equal to 184 against the alternative hypothesis mu less than 184. Find p value of the test first of all and find the critical region of the test, and then at 5% and 1%, for what values of sample mean will the null hypothesis be rejected at 5% level, and if the standard deviation is 5.2, for what values of sample mean will the null hypothesis be rejected at 1% level of significance. Okay, we shall see this. First of all, we have to compute x bar first of all, x bar and s value. X bar is all the 10 values are added together, 176, 180 plus etc. up to 184, all the 10 values are added and it is divided by 10. It gives you 1805. The total comes to be equal to 1805 divided by 10 is equal to 180.5. So, x bar is equal to 180.5. To compute s, x is taken first of all, then x minus x bar is taken, which is x minus 180.5, and x minus x bar whole square is taken. Okay. All these values are calculated and s is equal to root of summation x minus x bar whole square by n minus 1. Okay. And this value comes to be equal to root of 37.611 and root of s square value is 6.133. This is sample standard deviation value. X bar is 180.5 and a sample standard deviation is 6.133. Okay. After calculating this, we shall now step into find out the test statistic first of all. Then only we can find out the p value of the test statistic. What is the test statistic? Here the random sample size is 10, therefore it is a small sample. So, we use the t formula, t is equal to x bar minus mu divided by s by root of n. X bar is 180.5 and mu given in the question is 184 divided by S you have just calculated 6.133 divided by root of 10 is equal to, this is approximately minus 1.80. This is your t value. Okay. So, p value of the statistic is p value of the test is p of t less than or equal to minus 1.8, which is also equal to p1 minus p of t less than or equal to 1.8. Now, look at the t tables corresponding the nearest value to 1.80 is 1.83. This is a two-tailed area, right? For 9 degrees of freedom we have to see, because for t test the degrees of freedom is n minus 1, here n is 10. So, for 9 degrees of freedom you just look at where does 1.8 nearest value comes. In 9 degrees of freedom the nearest value of 1.83 occurs at 10 percentage level of significance, and this being a two-tailed area, we are talking about one tail because of alternative hypothesis is one tail. Therefore, we have to take a level of significance as 5 percentage, because this is for two tail, that is a 10 percentage. Therefore, for one tail it will be 5 percentage. This is 1 minus 0.95 is equal to 0.05. The value closest, actually we write like this, the value closest to 1.8 in t table with 9 degrees of freedom. 9 degrees of freedom is 1.83 and it occurs at 10 percentage. Therefore, we have the value as 0.05. Okay, because of the symmetricity we write 1 minus p of t less than or equal to 1.8. Okay, now the p value of the statistic is found out. Next we find the critical region. Second question is to find the critical region of the test at 5 percentage and 1 percentage level of significance, right. Second subdivision is to find out the critical region. We have p of t less than or equal to t star is equal to 0.05, okay, and we found where t star is equal to minus 1.83, isn't it. So, the critical region is all values, okay, for 5 percentage level of significance. The critical region is all values of t such that t is less than or equal to minus 1.83. Okay. Similarly, we discuss it for 9 degrees of freedom and 1 percentage level of significance. We see that it is 2.82. Just look at p of t less than or equal to t star is equal to 0.01 with 9 degrees of freedom. Look at the t table with 9 degrees of freedom and 1 percentage. This is actually two tail, right. This is two tail. Therefore, for 1 percentage we have to look at 2 percentage. Therefore, for 9 degrees of freedom at 2 percentage we must see, that is 2.82, this particular value. Because of alternative hypothesis is one tail and this particular table is for two tail, we have to convert it for one tailed. 1 percentage if you want, it is 2 percentage, 2 percentage 2.82, showing that we are taking 1 percentage level of significance for alternative hypothesis. 1 percentage is the level of significance for one tailed test. The table shows you the values for two tailed test. Therefore, we have referred for 9 degrees of freedom at 2 percentage level of significance, and the t star value comes to be equal to minus 2.82. Okay. Therefore, we see that p of t less than or equal to minus 2.82 is equal to 0.01, and we write all values of t such that t less than or equal to minus 2.82 is the critical region for 1% level of significance. Okay, what is the next question? The next question is, what values of sample mean will the null hypothesis be rejected at 5% level of significance? Okay, you are given null hypothesis as H naught such that mu is equal to 184. Given H naught such that mu is equal to 184, and we rejected the null hypothesis. H naught is rejected when x bar minus 184 by s by root of 10 lies in critical region. What is a critical region? Corresponding to 5% level of significance. We have just seen minus 1.83 is the critical region for 5% level of significance, isn't it? So, we have just seen P of a t less than or equal to minus 1.83 is the critical region for 5% level of significance. So, we take t is less than or equal to minus 1.83 for rejecting H naught. Okay, t means x bar minus 184 by s by root of 10 is less than or equal to minus 1.83, or we say that x bar is less than or equal to minus 1.83 into s by root of 10 plus 184, or we say that x bar is less than or equal to 184 minus 0.5787 s. So, the result of sample mean values when H naught to be rejected at 5% level of significance depends on this s. Therefore, sample mean values depends on s. What is the next question? If s is equal to 5.2, for what values of sample mean will the null hypothesis be rejected at 1% level of significance? So, first of all, again we have to calculate the same thing for 1% level of significance. We have just seen P of t less than or equal to minus 2.82 leads to the rejection region. T less than or equal to minus 2.82 is the critical region corresponding to 1% level of significance. So, T is minus 2.82 is the critical region for 1% level of significance, right. Therefore, accordingly we will take x bar minus 184 divided by s by root 10 is less than or equal to minus 2.82, given s is equal to 5.2. Therefore, x bar is less than or equal to minus 2.82 into 5.2 by root of 10 plus 184. Okay, and this value comes to be equal to 179.36. So, the sample mean values are x bar is less than or equal to 179.36, so that the null hypothesis is rejected at 1% level of significance. Now, look at the next problem. The useful time of Everlast 1.5 volts battery is a normally distributed random variable with mean 40 hours. This is population mean. Mu is equal to 40 hours and sigma standard deviation 4 hours. A new chemical composition is introduced to make the production of the batteries more efficient. And if you want to test whether the new chemical composition is going to efficiently increase the useful time of the battery. That is, the company wants to see if the useful time of the battery has been affected by the new process. Specifically, they wished to test the null hypothesis H naught mu is equal to 40 against the alternative hypothesis mu not equal to 40. It is assumed that standard deviation is still 4 hours. A sample of 100 batteries has a useful lifetime of 39.1 hours. Determine the test statistic and p value of the statistic. It is the power of the test at mu is equal to 39, assuming random sample of 100 batteries gives an average life of less than 39.5 or greater than 40.5. Also find the probability of type 2 error when mu is equal to 39. We shall work out this problem. Solution: first of all, statistic has to be decided since the sample is of 100 batteries, it is a large sample test, we have to use Z test for that. So, x bar minus mu by sigma by root n. Okay, x bar minus mu is 40 by 4 by root of 100 is equal to x bar minus 40 by 0.4. Therefore, the test statistic is Z is equal to x bar minus 40 by 0.4. Okay, next p value of the statistic. P value of the statistic is P of modulus of Z is greater than or equal to computed Z value Z1. Because of symmetricity we have 2 times because of the modulus. Okay, just see where Z1 is equal to x bar minus 40 by 0.4 with x bar is equal to 39.1. So, 39.1 minus 40 by 0.4 is equal to minus 2.25. So, p value is 2 times p of Z is greater than or equal to modulus of minus 2.25. 2 times p of Z greater than or equal to 2.25. Draw the diagram. We want for 2.25 greater than or equal to, right. Why it is 2 times? Because it is a two-tail test, both sides it has to be shaded. Actually Z is minus 2.25 or it is equivalently written as 2 times p of Z greater than or equal to 2.25. Okay. Now, what is this particular value? For 0 to 2.25, just see the diagram. Z is equal to 0, Z is equal to 2.25. You will see the diagram for this area and then 2.2, then 5. Okay. 0.4878, this value. 0.4878, this shaded part will be 0.0122. So, this is 0.0122. Therefore, our p value of the statistic is p value of this test. P value of the test is 2 times p of Z greater than or equal to 2.25, which is equal to 2 into 0.0122, which is 0.0244. What is the next question? What is the power of the test at mu is equal to 39? Assuming random sample of 100 batteries and gives an average life of less than 39.5 or greater than 40.5. When the power of the test is found out, you can usually find out probability of type 2 error, right. When x bar is equal to 39.5, your Z value is 39.5 minus 40 divided by 0.4, which is minus 1.25. Similarly, when x bar is equal to 40.5, Z is equal to 40.5 minus 40 by 0.4 plus 1.25. So, p of minus 39.5 less than or equal to x bar less than or equal to 40.5 will be equal to p of minus 1.25 less than or equal to Z less than or equal to 1.25. So, this is 2 times p of Z less than or equal to 1.25 and it is 2 times 0.1056 is 0.2112. Okay, the power of the test will be k of 39 is equal to p of x bar is less than or equal to 39.5 and at the same time x bar is greater than or equal to 40.5. So, p of x bar minus 39 by 0.4 is less than or equal to 39.5 minus 39 by 0.4 plus similarly p of x bar minus 39 by 0.4 is greater than or equal to 40.5 minus 39 by 0.4 and these two value comes to be equal to p of Z greater than or equal to 3.75, plus P of Z less than or equal to 1.25, okay, this value, and this is from the tables it is 0.8945. Hence, we have found out the power of the test. Next, probability of type 2 error is 1 minus k of 39 is equal to 1 minus 0.8945 0.1055. In this session, some more problems have been worked out in determining the critical region, power of the test and probability of type 2 error for a particular two cases. Based on the discussion in this session, the following questions may be posed. The sample mean of a random sample of 50 values of a random variable is 72.4. Assuming the null hypothesis is mu is equal to 70 against the alternative hypothesis mu greater than 70, compute p value of the statistic, power of the test, also determine the critical region of the test. Thank you.